Hey guys, Mr. T here, just doing a quick video on the sine rule. So the sine rule is useful for solving any triangle with sides and angles labeled thusly. So if you have an angle, usually written as a capital letter, the side is written in lowercase is always opposite to it. That's accepted in maths. So if you're labeled like this, A, B, and C, and all the opposite sides are also A, B, and C, then you can use the sine rule in this situation. And so the sine rule is this: the side length over the sine of the angle A, the side length of A, over the sine of the angle A is equivalent to the side length of B over the sine of the angle B is also equal to side length C over sine of the angle C. Now we always write it like this because that is a true statement for any triangle, but we only ever use two at a time to solve these triangles. So you're only going to ever see something like this. So to use the sine rule, there's a very specific condition that you need to have. You have to have an angle and the length of its opposite side. You need to know those things. And also you need another angle or another side length to be known as well. It's the only situation that you can use the sine rule. So let's do an example of finding the length of a side. You need to make sure your calculator is in degrees mode. Find the length of side C in the triangle below. So we have an angle and its opposite side known, and we have another angle known, so we can use the sine rule here. We have 7, the side length, over sine of 35, which is the angle opposite that side, is equal to C, which is the unknown, over sine of 105. Okay, now we can cross multiply. So I'll illustrate that with little arrows. So your next line of working is going to be 7 sine 105 degrees is equal to C times sine of 35 degrees. But I want C, so I need to get rid of the timesing by sine of 35. So I divide both sides by sine of 35, which will cancel out sine of 35 on the right-hand side. So C is going to be whatever 7 sine of 105 degrees over sine of 35 degrees is. Now use the calculator. 7 sine 105 divided by sine of 35. C is 11.79 centimeters to 2 decimal points. Next, find the angle B in the triangle below. So you can use this to find sides and angles. Let's check if it's a situation we can use it for. We have a side and its opposite angle, and now we have a side. So we're going to be using it to find this angle here. 5.5 over sine of 63 degrees is equal to 4.7 over sine of B. Cross multiply. I'm going to go to the right here because I might run out of space. 5.5 sine of B is equal to 4.7 sine of 63 degrees. I want sine of B by itself, so I divide both sides by 5.5. 5.5, that cancels 5.5 there, so sine B is equal to 4.7 sine of 63 degrees over 5.5. To get the angle, I need to use the inverse sine, so B is going to be inverse sine of 4.7 sine of 63 degrees over 5.5. So B, calculator time, 4.7 sine 63, divide that by 5.5, inverse sine of the answer to that is going to be 49.59 degrees to 2 decimal points. That's angle B. Now it's tricky with the sine rule because we have to be aware of something known as the ambiguous case. When you're using sine rule to find an angle, but you're given two known sides and an angle that's not between the two known sides, so not an included angle, there is a possibility that there's actually two legit answers. This is known as the ambiguous case. I can show you or illustrate the possibility of this with a diagram below. So the existing triangle, the question that you might be interested in might look like this. But as you can see, I can keep A the same length here, right? I can keep A the same length and swing it around. And this angle at corner A is going to remain the same. So I've got two possible triangles that are going to have a side that is the length of B, the side that is the length of A, and an angle the size of this capital A here. There's two possible triangles that fit that criteria. Now the reason why this occurs is because the sine of an angle is equal to the sine of 180 degrees take that angle. They're exactly the same. So as you can see in the diagram above, the angle at C can be increased. This angle here, I can make a larger angle there, while keeping A the same length, producing another valid triangle that has the same angle at this corner A. So the way that you should deal with this is like so. 5 steps. To determine if there's actually two possible answers from using the sine rule, number 1, check that your situation is finding an unknown angle with two given sides and a given angle that's not between those sides. It's not an included angle. Step 2, find the value of your unknown angle as normal. So answer the question. Step 3, once the unknown angle is found, take it away from 180 to find the new possible angle it could be. Add the new possible angle to the angle you are given in the question. And lastly, if the sum of the addition you did in 4 is less than 180, you actually have two valid answers. You need to show them both. If the sum is greater than 180, then the second angle isn't a valid answer. You don't need to provide both answers. So let's do an example here. Find the angle B in the triangle below. We have two given sides and the angle that we know is not between them. So we have this situation that we need to be aware of. So 6 over sine of 33 degrees is equal to 10 over sine B, which is the angle we're trying to find. Now we have cross multiplication. 6 sine B is equal to 10 sine 33 degrees. Sine of B is going to equal 10 sine 33 degrees over 6. To get rid of the multiplying by 6 on the left-hand side. And then to get B, I need to do the inverse sine of 10 sine 33 degrees over 6. So B is going to be 10 times sine 33, calculator time, divided by 6, inverse sine of the answer. B is going to be 65.19 degrees to 2 decimal points. However, I'm aware that in this situation, I could have an ambiguous case. So the steps were, I found the value of the unknown angle as normal. Once the unknown angle is found, subtract it from 180 to find the new possible angle. So 180 minus 65.19 is 114.81 degrees. Add the new possible angle to the given angle in the question. Possible, so I'll write here possible ambiguous case. I need to add this to the angle I was given in the question, so 114.81 plus 33 equals 147.81 degrees. If the sum is less than 180, you have two valid answers. If the sum is greater than 180, then the second angle is not a valid answer. So we have two possible answers here. So B is either 65.19 degrees or the possible ambiguous case of 114.81 degrees. All right. So hopefully that video helps you out on the sine rule and using it to find sides and angles, and also about the ambiguous case. And I will see you in the next video.